everyone, this is the fourth video of design pattern series, and today we are going to discuss about how to ensure thread safety in Singleton design pattern. So I have demonstrated four ways to achieving this. The first one is ThreadLocal, where we will be having one instance per thread. Of course, that is not efficient way of achieving the same, so we are going to look into another way, which is to define the method where we are initializing the reference variable as a synchronized method. Again, here we will have a more locking period, right? So because we are defining the lock on the entire method, so if multiple threads are using that method, they will be waiting for longer time. So instead of doing this, we have doubly checked locking, where instead of applying the lock on the entire method, we will apply the lock only on the specific part of the method which we know that we need to make the thread safe, right? Then it is the most efficient way and the most easy way that I could find out, that is using the static inner class. So let us discuss these one by one in IntelliJ. So this is how we created the singleton class of schema manager in our previous video. We had a reference variable of schema manager and we were initializing it only when the current value of the schema manager is null. If it is not null, then we were returning the current value as it is. Now to make it thread safe, as we discussed, the first approach is to use ThreadLocal. So here we have defined the same reference variable which we have here, this one, as a ThreadLocal. And what you need to do, use ThreadLocal keyword and pass the generic as the class here, and this is your same reference variable. Now this is exactly same how we have achieved in our previous class. Like, we just need to access the ThreadLocal with the help of set and get method, right? If get like schema manager dot get equal to null, then set the value, otherwise just get the uh, value whichever you have, right? Now the con of this particular one, as we discussed, we will be having one instance per thread, which is not an efficient way of doing things, right? So the next way is to use synchronized method. So here we have the same like reference variable defined without thread local, and we are just having the synchronized keyword on the method which is initializing the instance. Now here what is happening, we are not creating instance per thread, but we are increasing the lock period. So if suppose there are five threads running in parallel, the first one starts to work on this one, so there will be a lock established on the remaining four until or unless the first one is able to complete the processing, right? So this is like kind of better way than the thread local, because we are not initializing uh, the reference variable for each thread, but we have a longer lock period here. So for solving this, we have this way where we are having doubly checked locking. So what we do here, if I go to the top here, now in doubly checked locking strategy, as we discussed, like instead of locking the entire method, we will just lock the part of the method where we know that we need to ensure the thread safety. If I show you here, like this is the part where we need to ensure the thread safety, where we are initializing the reference variable. Now, if you see the case where the reference variable is already initialized, which will happen most of the time, this synchronized bit will not come into the picture. Thus, locking will not happen. Thus, it is more efficient as compared to the previous state where we were making the whole method as a synchronized method. Now, if we focus on the synchronized bit, here we can see that we are again checking whether the current value of the reference variable is null or not, right? So that's why it is doubly checked. And then if the value is not null, then come out of the if condition. If it is null, then initialize the value as earlier, right? Now this is how doubly checked locking strategy works, but we can make it more efficient. How? If you see this particular um, reference variable that we have defined it as a volatile. And what volatile means is that we are letting JVM know that in case there is a reference variable which is being shared by the multiple threads are operating on that. So whenever a thread is accessing that reference variable, always provide the most updated value, the recent value, right? Because every thread will have their local memory. So instead of using the local memory, use the global one where we have the most updated value of this variable. So due to this particular thing, the operations on the volatile variables are expensive. So to reduce this part, what we can do is to reduce this performance issue, a little bit of performance issue that we will have due to the volatile variable, we can define our non-volatile variable of the class reference variable, right? And store the current value in this of our volatile reference variable, of course. And now perform the assertion like the if condition on this particular non-volatile uh, reference variable. And when we need to update both volatile and the non-volatile reference variable at the same time. So this is also more efficient way, one of the more efficient way than the previous one of doubly checked locking strategy. So this is how it is done. Now let me discuss about the last part, which is to use static inner class, and it is really simple as compared to what we have discussed till now. There is no if condition, there is no synchronized block, there is no volatility or volatile keyword defined, there is no thread local. What we have to do? So here we have the private constructor, right? And we do not need the reference variable defined here. So this is how it is different from the previous way of implementing the thread safety, and also the singleton pattern that we had previously. In each of them we were having the reference variable of the class here, but here we do not need it. So how it will be handled? It will be handled with the help of this inner class, private static inner class. So here what we have the property defined of the inner class, which is nothing. This property is the reference variable of our outer class, and here we have the reference defined. As we have the private constructor of the outer class and this is the inner class, it will be able to access the private constructor, right? And now when this get instance or get schema manager method will come into the picture, this inner class will be loaded at that time, right? And JVM will ensure that it is lazily loaded. Lazily loaded means it is thread safe, right? And if I show you now how to execute the test in parallel using, so I have implemented, I have shown you all of these ways, but in the demonstration, I'm going to use this one. So here I have six methods, six test method defined, and each of one is using this static inner way of ensuring the thread safety. And here I have my testng.xml file and I'm executing it in parallel. We have a thread count of 5. Let me make it 6 because we have 6 tests, right? And now if I go to my class again, I will just execute it. You see all 6 of them are being executed at the same time and all of them are passed, right? So that's all for this video, guys, and I will share the GitHub link of the source code into the description section of the video. And in case you're liking the content that I'm making, please do like, share, and do subscribe. Thank you, guys. See you in the next video.